Good morning, distinguished panelists, chair, session chair, and distinguished delegates. And thank you, MBI, for giving us this opportunity to present here. So when this opportunity was given to us, I thought it's quite a open theme. So I was lost a while, and then I thought, okay, let me talk about the technologies that give a broader perspective of, we are a technology company, to give a broader perspective of exploration technology. So that's where I have basically put the slides around for the next 15 minutes, and we'll put, of course, we'll add some learnings through the projects, exploration projects that we have done, and we are privileged to do a big projects with Ken recently. Okay, I'll skip this slide. So I begin with this slide quite often from the trend wise. So if you look at the slide, the initial jump in exploration was structural for sure. For if you look at on the x-axis is the year, and on the y-axis is the cumulative curve. So if you look at the initial jump came from the structural, and these are coming from publications. The key focus is, if you look at the late 2000 or late 20s, it's mostly coming, the jump incremental benefit is coming from stratigraphical or the combination traps. That's quite interesting. So, and that's happening because of both better imaging, improved processing, wide azimuth data, and modeling, a lot of modeling into it. So these are technologies basically giving incremental addition to the discoveries. And on the right, there are different risk factors which are again published by in different journals. Apologies if it is not readable, it's quite a crowded slide. But in general, if you look at the mature basins, the charge risk is low, but the both seal and reservoir they carries quite a big risk. And in the frontier side, less exposed basin, everything carries a risk. Of course, if the seismic data is good, then reservoir risk is minimized a bit, but the rest of the risk, whether it's charge, primarily charge, it still relies a lot on the modeling space and mass balancing, on hydrocarbon mass balancing. So with this opening, I will basically touch upon the Schlumberger technology portfolio one by one in each space, and we'll give a value proposition remark. For some of you who are domain expert in a particular domain, it may sound quite introductory, so please excuse me for that. So we have been involved in quite a lot of exploration studies. No, though we're not allowed to present the data here. But in general, the workflows, everybody is aware that in the seismic domain, there is Schlumberger offers a lot of advanced processing and data enhancement techniques. Then of late, there's quite a bit of advancement in volume-based modeling and forward stratigraphical simulation. So I have a slide on forward stratigraphical simulation to touch upon. And then once a better image is produced from a better interpretation, sequence interpretation, improved image, and a forward stratigraphical simulation is performed, that goes into a petroleum system model, and understand the overall hydrocarbon mass balance, the fairways, and de-risk both seal as well as the charge. That's what petroleum system modeling space talks about. And finally, prospect generation, and the big part of it is actually the portfolio analysis. How to do it's a standard approach and unbiased approach for both play and prospect de-risking. Everybody knows it. It's common practice since years, but the key is unbiased and standard auditable techniques, so that we always compare apple to apple. So that's what is one of some my personal experience on portfolio and play risking. Okay, this I'll skip quickly. It's just since because I'm covering the whole technology space, so I quickly put some of these slides. So petrophysical joint inversion. This is basically, we know that seismic inversion is not that sensitive to the saturation. Of course, porosity, we can invert for porosity and other properties, but the saturation is less sensitive. So a petrophysical joint inversion using CACM can bring that saturation value, especially where saturation is a high risk in many places, especially in the offshores. Then potential fields. Potential fields again carries a lot of value. So some of relevant, gravity magnetics, Sudhir ji just showed. It brings tremendous value to mapping lineaments, basement structure, and of course the first investigation is for the basement and lineaments, but subsequently even the internal stratigraphy can be inverted using seismic and well logs. So that brings that open that not just for the stratigraphy but also for better imaging. If you do the seismic joint inversion of the density with the near surface, so there is a lot of near surface noises can be reduced with that. And another bigger application down here at the corner down below in the slides is basically understanding the heat flow. For the frontier, understanding the heat flow and how crustal and mantle thickness evolves over time is one of the critical input in petroleum system modeling. So that is again input from this from density inversion, 2.5D inversion on source. These are well-known techniques in advanced seismic, forward full waveform inversion and density Q compensations, and then using higher velocity, using tomography, creating a better model, and then improving the image. So these are just a glimpse of technology that is in our portfolio. This one is a recent addition and coming up quite a lot and being recognized lately quite a lot. So forward stratigraphical simulation is basically it's a frontier tool. It's a frontier exploration tool where initial basin topography is considered based on reconstructed initial basement or initial surface that is to be modeled, and then boundary conditions are applied to the model, like provenance, sediment supply, sea level variations, and a forward simulation of the stratigraphy is performed based on various processes. It could be diffusion. It could be diffusion is sediment, simple mass transport. It could be wave action, river action, turbidite action, so on and so forth. So there are many ways to forward simulate. So this technology is attracting attention in frontier areas. Of course, it's a lab, so it should be done as experimentation technology or as a lab rather than a time bound, because many times the time bound projects expectations do not match because it's experimentation. Simple words. So this is one of the examples from the US, where these are the wells behind the outcrop, and then they are stratigraphically interpreted. The initial framework was just the bottom one. The bottommost one is the first surface, and the rest, and then these are the boundary conditions that you see on the left corner, tectonics and sea level, and the resulting simulation is that. So that resulting simulation then helps to perform a much higher resolution, much better level correlation, which was otherwise sometimes difficult, especially the low stand bypass zones, which are very hard to sometimes pick based on intuitive correlation. Even the experienced stratigraphers sometimes can miss them. So and then this the rock mass or the grid, the simulated sequence stratigraphical grid, this can be converted back to either seismic by convolving a wave, and then compared with the seismic. So calibration is in the real example, a bottom surface, and then calibrating with the wells, or if this is the input, then calibration with the seismic. So this is how it's a back and forth, but of course it's an experimentation process. It's a sedimentary lab in a simulator. So this technology is getting a lot of attention of late. This one is one of my core areas. So again, workflow is well known. What recently done, petroleum system modeling workflow is well known. Everybody understand it. One of the bottleneck in petroleum system typically is a specialized group that does it, and we notice that they, whether competitor or our, they are a bit isolated from the mainstream. Mainstream means working in the main workstation. For example, for us is the petrol, where all the data is sitting. So off late, it's integrated. It's now everything is possible through interpretation interface that is through petrol. That reduces a lot of time. One. Second is these recent advances. Initially, conventionally, the petroleum system models were performed using the regional GDs, a gross lithological variation, understanding overall mass balance problem, where the hydrocarbon are flowing in general. That's the conventional use of it. However, now since we have high resolution models, forward stratigraphical simulation or inversion, high resolution cubes, these all can be fit in. Down bottom at the slide, these all can be fit into the regional model, put into the regional model, and where in the area of study. For example, if you have inversion in a where the company is doing prospecting, so in that particular area, that high resolution, the bigger the parent model can be replaced with the high resolution model, and again on the simulator, so that a high resolution migration modeling and stratigraphical trapping, these all things can be investigated in much higher resolution. Otherwise, the regional grid is not good for prospect level investigation. It is good for a regional de-risking, overall hydrocarbon mass balance investigation in general. So these are the recent technological advances in petroleum system modeling. Yeah, one here, my comment is, again, it's used. Everybody does it. It's there in the industry for many years. Play-based exploration approach is well known. The key is really unbiased, standard, and process-driven. So if it is done that way, then it makes auditing easy. It makes decision-making easy. The way we do it, basically, we we have all the trap elements, or with in consortium, in all the consulting projects we have been involved in, is basically map based. Create the map for all the reservoir elements, trap, reservoir, charge, seals, or whatever company's risk model is, and then create place segment together and combined risk segment, and everything is linked through data input rather than personal biases or judgmental variation. So it's a process driven, auditable process driven. That's what I wanted to emphasize. And then of course create the assessment units. Post the play segment, create the assessment units, and these assessment units, and then of course assessment units or play segment, and in these play segments, then the risk is easy to pick from there. So whether once this template is ready, whether we are doing de-risking the play segment, or investigating or risking the prospect, all elements becomes easier, except the conditional risk. This is a shared risk applicable at the play level, except the conditional risk, which is like fault seal. That is of course individual. And then we follow a probabilistic approach. Again, I have seen through my consulting experience, I've seen many times a fully probabilistic approach is not used, or risk-weighted probabilistic approach is not used. Where it helps really is one, because in the explosion we cannot go deterministic. It's a too much simplification, and then when there are multiple segments of a prospects, then dependencies between the segments, dependencies between the play, these has to be these cannot be done in a deterministic way. These has to go through the pure probabilistic way. So that's what the tool helps. And also at the last, if you see at the last corner, a master database. This is one of the bottleneck, or one of the pain points, that there are many prospects lying different Excel sheets at different places, and it becomes hard for the decision maker to decide. But if everything is in one place, in a very structured manner, with risk, with full statistics, with full probability, then it makes life easy for the decision makers, and also the auditors, decision gate approvers. Well, I will. How much time do I have, sir? How much time do I have? Okay. So I'll skip this slide. This is basically, I have more or less talked. There are certain things through my experience. Now these things I have put up through my experience. It's gross rock volume is fine, but there are a lot of biases when it comes to NTG and porosity. It happens. So being mindful about that is key, and of course then that inflates, that makes and breaks the prospect. Risk dependencies and the trap fill scenario based on the sealing scenarios. Again, many times it's not done as rigorously as it should be, and end of the day, then a higher risk, the both risk and volumes, they get biased. And when it comes to the portfolio level, then the play-based approach. So maybe I'll leave this part, and we'll go to the last slide, that is on. I'll leave this slide too in the interest of time. Okay, so SLB has a big focus on digital space, AI and ML space. So what we are doing on exploration side, if you see, this is one of the pain point, as I told, is putting everything together in one canvas and making higher management life easy for the decision. So one of the technology is Explore Plan in that context, where everything, all the input analysis are put in the same context, and they are auditable. And the way the industry likes to look at the portfolio in a funnel shape, the volumes, the risk, and maturity with a steam gate, and on a button click it can be done cloud-based. The other things that are happening, there are a lot of ML-based fault predictions, ML-based horizon interpretation, ML-based faces predictions, and they are quite open now. They are available in open space now. So the way they are implemented here are through joint collaboration. So these are not basically a ready-made solution, rather a joint collaboration solutions. So because training is key. In any ML-based investigation, training the data is the key. And that training, different companies follow different procedures to train the data. So that's why they are liberated. They are separated through tools like Spotfire and Dataiku and Spotfire, so that it can be done together, and then machine learning can be optimized in the backspace. So the basic training is liberated from the cloud computing, and then of course algorithm runs in the background. So that gives a broader overview of exploration offerings from Schlumberger portfolio. I hope, I know I went through very quickly from some of them, and it could be quite introductory for many domain experts. So would like to hear from you offline or now, whatever you like later. Thank you for your attention.